So today we're going to talk about the syntax and semantics of the program development process. And as I promised you, we're going to do an in-class exercise very close to your first programming assignment. So, we've already seen that a program is composed of several functions. And in fact, in our lab, we wrote a function, a main function, and we'll continue to see this. We'll take a look at a little bit of syntax templates, but more than anything else, we'll talk about these identifiers, these names, and how to assign values to those verifiers, those identifiers, and the difference between a name constant and a regular variable. Okay? Let me move forward this time. While you're doing that, just give me forward the slide. Okay. So we, as I said in lab last week, we put together a main. Why don't you try to do this? Maybe it's the proximity. That's the issue. Okay. Well, we still continue on. You can flip it around, because I'm going to use this video for the website. So go ahead and flip it around. So we know that every program in C++ has to have a main function. And please, folks, I'm seeing everybody keying on your keyboard and looking at your screen. Focus on me, please. Let your email go. Let your email go. Let it go for a minute, all right? Execution begins with the first statement in main. There's always going to be a main function and generally other functions that will be executed from main. Think of this in terms of our structure chart we looked at. In terms of producing a party, we have a main person who's controlling everything, and then there are other functions or subtasks that are being run and executed by main. So let's take a quick look at a set of functions that are being put together to comprise a C++ program, a main function, a square function, a cube function. Here's our source code, and some of this should begin to be familiar to you. You've seen this int main, and we worked with this namespace on Monday. What we didn't see, and what's probably new to you, are these two statements. These are called function prototypes. What we have to do here is we have to declare, like we declare a variable, we have to declare a function. And to do that, we put together a statement that establishes a function name, a parameter, we talked about that a little bit last week, and a return type. This is going to be a function that computes the square of an integer value that it takes as a parameter, and it's going to return the square of that integer value as a return from its execution. And so, as we see here in the first statement in main, the cout is the statement that's going to send it out to our console window. The square of 27 is, and here we see a call to that function square. And we send that function square a integer value 27. And execution control stops here, is given to that function, while that function operates on 27 and produces its square, 27 times 27. Execution control will stop being in the main, but will be given to that function. I'll show you that function in just a minute, but you can imagine what it does. Once it finishes, its value is returned right back here, and so the output of this program when it executes will be the square of 27, will be some number. This indel causes a line to the script or the cursor to move down to the next line. And then the second statement in the main is the cube of 27, and then the second function, cube, is called with the same integer parameter 27, and it returns, as you would expect, the cube of 27. One more slide. Here are our functions. The square function simply returns n, which is the value that it was sent, and for our execution, it was the value 27. It was placed in memory at a memory location called n, and then this function's single statement returns an expression that is evaluated, and again, it's just simple mathematics, 27 times 27. And similarly, the cube function takes on, and notice these are different values. These are called local variables, or in this case, parameters. They are and can be named the same thing, but they're not the same place in memory. They're not the same place in memory. And here we now have the output of our program, which is, as I promised, the square of 27 is that 729, and then this is also then the cube of this. Any questions? These slides, by the way, I'll be putting on the web. And for those of you who have not learned how to manipulate this intranet, when you go in with your login ID, you're going to see a set of menus on the side, on the right-hand side. The very last one, or the one next to the last, is go to the course website. That course website is where you can find these slides, and hopefully you form the today's lecture. Okay, so here we have the basic structure of our main function. It begins with a return type. The name is always main. It never takes a parameter. It must end with this instruction, return 0. And that 0 is the return value from the main function. Now just a quick note, why does main return 0? Well, 0 is the indication to the operating system that this program terminated properly. In other words, all the instructions in main were executed. It got to the end. It terminated. It stops executing. And it returns a value to the operating system of 0. Yes? 0 is like true. It's like true. If you have a sequence of programs that run, let's say it's a program set that produces a paycheck. It has to produce, one program would go off and produce a state tax, another program would run and do the federal tax, another program would look at your hours, another program might go to the printer and print the actual paycheck. All these programs run with sequence. And from the operating system's perspective, these are just pieces of code that execute. But any one of those statements, those programs return a 1, meaning it did not terminate properly, then the whole process stops. It doesn't go again and print out 30,000 blank checks or check the errors. So when you have things that are critical, sequence of programs that run right after another, this return 0 becomes a little bit important to make sure that it doesn't go to the end of that sequence of programs. So, but for your sake, we're going to be executing just single program, so don't be too concerned about that. Yes?
Well, what would make a program not return 0?
Let's say it was trying to read a data file and the data file wasn't there. Or let's say it was trying to read a CD where the data file was and somebody scratched the CD or the CD was damaged. Or perhaps it was trying to read a value for a name to go on a check and there was no name there. You can't print a check without a name. So it would stop. And the programmer or whoever would be called and some coming fiction program and the execution sequence of those programs would either be started over at the stop part where it started, where it got the error is corrected, then we move forward, or more than likely it would be started all the way over at the beginning, and now the process should go through without anything other than a 0 being returned in the individual program in the sequence. Okay. Again, these are things that are more complex than I think you're going to deal with in this particular course, but it's just good to know. So you're always going to have return 0, you're always going to have input. Okay? So, just a little bit more about this header. It has a return type and a name, and it's blocked in braces. Okay. As I said, no parameters. And the braces are a body of statements, curly braces. And in some cases they're optional, but in our program we'll always have code within those braces. So we have the heading here, and of course the body of block. Yes? I said in our particular use of the C++ language, we'll never have braces that do not have instructions in the body. But it is possible to have a function that has no instructions. In the sense of, so we've spoken a bit about our identifier earlier, and we want to make our identifier names as meaningful as possible. Okay? So let me begin now to describe the in-class exercise that I want you to do. And as I'm talking, it would be a good idea if you all would be starting a project in Visual C++, call that project in-class exercise 1. And we're going to declare a number of variables, and we're going to use those variables with an output statement and output the sum of those variables. Very simple program. But the variables, the identifiers that I want you to define for today's in-class exercise are going to be named very specifically. Very specific. And those names are case sensitive. So if you declare a variable by the name of hourly underscore rate, you cannot later in the program refer to the calculator. So it's very case sensitive. You declare something by a particular name, you need to refer to it exactly as it was declared. That's what the case sensitive is. So you can begin to prepare a program, a C++ program, for today's in-class exercise. I want you to define for me a float variable called hourly rate. I want you to initialize that float value at 0, 0. I'm going to take a second and walk around and see if I can get you just to that point. Everybody started to get this thing done, and as we work through the lecture, we're going to be adding to this particular program that you're developing. So, can we stop there?